In 1848, when a guy was standing in the stream and he looked down and there's gold, and gold was really easy to find at that time, and so people came from all over the world, a lunar moon rush and lunar platinum development is going to require a lot of capital. On the moon, it's going to be capital intensive. In the typical chicken and egg irony that is space, no one is going to go and do it until someone goes and does it. So you've got to find someone who's either crazy enough, stubborn enough, and rich enough. The first thing that we're going to do is obviously oxygen. I am not as enthusiastic about the lunar ice as some of my compatriots are, because of the difficulties of operating in an environment that's only 35 degrees above absolute zero. That imposes tremendous requirements on your machinery. Metals that perfectly bend in a room environment would shatter like glass at those temperatures. Unless we find deposits of lunar ice that's pure ice like meters thick, I don't think the lunar ice is the first resource. I think oxygen, either from regolith derived at the poles or regolith from locations other than the poles, will be processed into oxygen. The key determinant of what happens next is kind of the way that you do the oxygen production. For every ton of oxygen that you produce 2.4 tons of iron. The in situ resource process that will work is a process that actually takes and considers the other elements that come from the oxygen production and produces those simultaneously. And if you look at them in sequence of temperature or volatility, it's magnesium, it's iron, silicon, and then you get to aluminum. Those are the four that's in any regolith that's on the lunar surface. And those metals can be used for building habitats, because I think the most important thing that we need to do on the moon is create as much living space as possible, as quickly as possible.